The topic of aircraft performance, let's dive a little bit deeper into density altitude. First off, how does the FAA define density altitude? The FAA calls it pressure altitude corrected for non-standard temperature. Okay, great. What does that mean for me and my aircraft performance? Well, not a lot. Let me give you my definition for it and put it into layman's terms. Density altitude is where the airplane feels like it's at. Here's an example. If density altitude is 3,500 feet at the surface, the airplane is going to perform as if it's already at 3,500 feet. For our normally aspirated engines, our engines that need that air to breathe and to function, we're going to have a decrease in performance. You should know by now, if you've done any flying, that your aircraft performance decreases with altitude. So if density altitude at the surface is already 3,500 feet, I'm going to have a longer takeoff roll. I'm going to have poorer climb performance. My performance is overall going to decrease because of the increase in density altitude. Now, what factors contribute to density altitude? Well, the three factors that increase density altitude are high temperature, high humidity, and high elevation. And I can tell you, being based in Florida, you only need two of them to really decrease that performance. We get the high temps, we get the high humidity. Despite not having the high elevation, we still, in the summer, deal with 3,000 and 4,000 feet worth of density altitude just here at the surface in June at 3 p.m. in the afternoon. Now, go fly in Denver in the summertime, where you have the high elevation and the high temps. You may not have the high humidity like we do here in Florida, but you still experience that density altitude. And obviously, the elevation is the biggest factor to that because you're already at a higher altitude. Now, how do we calculate density altitude? There's a lot of ways to do it. There's plenty of apps, there's plenty of formulas, but I want to show you the old-fashioned way because this is how you'll be asked to calculate density altitude on your FAA written test. And these are actual FAA written test questions here. They read like this. Determine the density altitude. The altimeter is 30.35. The runway temperature is a positive 25 degrees Fahrenheit. They're trying to trick you. I don't know why they give it to us in Fahrenheit when everything we do is in centigrade. Your airport elevation is 3,894 feet. First things first, we need to find our pressure altitude, that column on the right. So we take our altimeter of 30.35. We split the difference between 30.30 and 30.40. We interpolate between those two numbers, and I get roughly about a negative 394 feet. I subtract that from my field elevation to get a pressure altitude of 3,500 feet. I now take my temperature of a positive 25 degrees Fahrenheit, where that arrow just popped up there. I then take that using my brown lines there you see and find 3,500 feet, which is my pressure altitude. I take that straight on up to my pressure altitude of 3,500 feet. I carry it on across, and I get a density altitude of roughly about 2,000 feet. My airplane sitting on the ground will perform and feel like it's already at 2,000 feet. Let's look at another one to help it kind of all make sense for you. Altimeter, 29.25. Runway temp is a positive 81 degrees Fahrenheit. Airport elevation, 5,250 feet. Let's take a look at that altimeter and get the pressure altitude. Up a little bit higher this time. I've got to interpolate again between my 673 and 579. I do a little subtraction to get the difference between those two, and I get a positive 626. Since it's a positive number, I add it to my field elevation to get a pressure altitude of 5,876 feet. I now take my temperature, that positive 81 degrees Fahrenheit. I take it all the way up to my pressure altitude brown line of 5,876. I read it straight on across to get a density altitude of about 8,200 feet. my airplane, my Cessna 172, sitting on the ground is going to perform and feel like it's already at 8,200 feet. Considering the airplane only has a service ceiling of 14 to 15,000 feet, I'm going to be real limited about when and where I can actually fly. In fact, I know from flying out west plenty of times with some great mountain flying pilots that they have no fly days based on density altitude. I've been out to Leadville's Lake County Airport, the highest paved airport in North America. And meeting with the airport manager, he said there's days where we're just closed to normally aspirated aircraft. They only are open for, turbine powered or turbocharged aircraft because no one else can get in and out of there in a normally aspirated aircraft without a turbocharger because the density altitude is just way too high to even leave the ground, as crazy as that sounds. Let's look at another one asked a little bit differently. What is the effect of a temperature increase from 35 degrees Fahrenheit to 50 degrees Fahrenheit on the density altitude if the pressure altitude remains at 3,000 feet? Well, you just have to think about this differently. Let's calculate it twice. Let's calculate it once for 35 degrees Fahrenheit up to my pressure altitude of 3,000 feet, take it straight on across, and I get a density altitude of, let's call it roughly about 1,900 feet. Let's do the same thing now for 50 degrees Fahrenheit. Same thing, 50 degrees Fahrenheit, straight on up to 3,000 feet, and then straight across, I get, let's call it 2,900 feet. So roughly, it's a 1,000-foot increase. Pressure altitude remains the same. I just increase that much in temperature and I get a 1,000-foot increase in density altitude. It really shows you the impact of high temperature on our density altitude. I know there's a lot of different ways to calculate density altitude. Geez, some ATIS, ASOS, AWOS actually give you the density altitude when you listen to it before departure. I don't care how you calculate it. This is a way you need to learn, though, for your FAA written test. But as a real-world pilot, you can use an app. You can call the flight service station. You can listen to the ATIS to get it. However, it's so important that you do gather that information because all your takeoff calculations, landing calculations, cruise performance calculations will be done in vain if you don't know the density altitude. It's that important, and I challenge you to calculate it before each and every flight.